Let p of x equal x to the 8th plus x to the 6th plus 1. Then p of x has 8 different complex roots, r1 through r8. Let s equal the sum of ri minus rj times ri to the 7th plus rj to the 7th over ri to the 6th minus rj to the 6th, where the sum is taken over unordered pairs ij. What is the magnitude of s? We have to concentrate on the expression that is being summed. We can simplify this expression. It's equal to ri to the 8th minus rj to the 8th plus ri times rj to the 7th minus ri to the 7th times rj. And all of that over ri to the 6th minus rj to the 6th. We can see that these two terms are each a multiple of ri times rj, so we can factor that out of the expression, and we get ri to the 8th minus rj to the 8th minus ri rj times, the first one is minus ri rj times negative rj to the 6th, and the second one is minus ri rj times ri to the 6th. So if we add those up, it would be ri to the 6th minus rj to the 6th over ri to the 6th minus rj to the 6th. And we see that these two numbers are the same thing. So we can just do ri to the 8th minus rj to the 8th over ri to the 6th minus rj to the 6th minus ri rj. And we want to sum this quantity over unordered pairs ij, where I and j are between 1 and 8. Now, it might be useful to recall the definition of ri and rj. The roots of p of x equals x to the 8th plus x to the 6th plus 1. So any root r of p of x is going to satisfy r to the 8th plus r to the 6th plus 1 equals 0. And ri and rj are roots, so we can apply it to them. Let's see what we have. We can rewrite this r to the 8th plus r to the 6th plus 1 equals 0 as r to the 8th equals negative 1 minus r to the 6th. So we can apply it to ri and rj here, since they are roots of p of x, equals x to the 8th plus x to the 6th plus 1. So we have negative 1 minus ri to the 6th minus negative 1 minus rj to the 6th over ri to the 6th minus rj to the 6th, and all of that minus ri times rj. And we can simplify, we can greatly simplify actually, the term on the numerator. That is equal to negative 1 minus ri to the 6th plus 1 plus rj to the 6th over ri to the 6th minus rj to the 6th minus ri rj. The negative 1 and the plus 1 cancel out, and we're left with negative ri to the 6th plus rj to the 6th over ri to the 6th minus rj to the 6th, and that's just equal to negative 1. So we want the sum of negative 1 minus ri rj. So we want the sum of negative 1 minus the sum where I and j are taken over unordered pairs between 1 and 8 of ri rj. The second one is easy. That's just the sum of the roots taken in pairs, which by Vietas is equal to the x6th coefficient over the x to the 8th coefficient. And that's just 1 over 1, which is 1. So we want the sum where 1 is less than or equal to I is less than j, is less than or equal to 8 of negative 1, and all of that minus just 1. This value on the left can be computed pretty easily. Well, there are 8 choose 2 pairs, I and j, because I is less than j, and they're both between 1 and 8. So that's just the number of ways to select 2 integers, I and j, between 1 and 8, and that's just 8 choose 2. And each time, we're adding negative 1. So this is just negative 8 choose 2 minus 1, which is negative 28 minus 1, and that's equal to negative 29. They want us to find the magnitude of s, and the magnitude of negative 29 is equal to e, 29. So thank you all for watching my YouTube video. and good luck on the AMC 12B on Tuesday, November 14. Unfortunately, the confidentiality of the AMC 12A, which was supposed to take place this Wednesday, November 8, has been ruined because someone posted the problems online early on Saturday, November 4. So that's out of the picture for most of us. Our only hope is the AMC 12B. Good luck on the AMC 12B, and please help us get to 200 followers before Tuesday, November 14, the AMC 12B.